Light feels simple. You see it every day. It fills your room. It reflects off surfaces. It lets you see the world around you. And if someone asked you what it's made of, you'd probably say the same thing most people do. Photons. Tiny particles of light. That's the answer we're given. And it's not wrong, but it's not the full story either. Because the deeper you go into this question, the less clear that answer becomes. Is light really a particle? A wave? Both? Or something else entirely? Because depending on how you look at it, light changes. It behaves differently. It refuses to stay in a single definition. And that's where things begin to get strange. Because when something can't be pinned down, when it doesn't fit into the categories we expect, it usually means we're missing something deeper, something more fundamental. Tonight, we're going to slow this down and step beyond the idea of photons into what light actually is. Not just what we call it, but what it really might be underneath. When you hear the word photon, it sounds simple, like a tiny object, a little packet of light moving through space, something you could almost imagine as a small ball, traveling from one place to another. And in some situations, that picture seems to work. Light arrives in discrete amounts. It can be absorbed, emitted, detected as individual events, as if it really is made of tiny pieces. But then something doesn't add up, because in other experiments, light doesn't behave like particles at all. It spreads out. It interferes with itself. It creates patterns that only waves should be able to produce. And not just occasionally, consistently, reliably. So now you have a problem, because light is acting like two completely different things, not switching between them, but somehow being both. A particle when you measure it one way, a wave when you measure it another, and neither description feels complete on its own. So when we say light is made of photons, what we're really doing is giving a name to one aspect of its behavior, not its full nature, not its full identity, just one way it appears under certain conditions. And that raises a deeper question. If photons are not the full story, then what is light? When you stop trying to force it into familiar categories. If calling light a particle doesn't fully work, the natural next step is to call it a wave. And for a long time, that seemed like the better answer. Because light spreads out, it interferes. It creates patterns of peaks and troughs, just like waves on water. In experiments, you can shine light through two tiny openings, and instead of getting two bright spots, you get a pattern, a series of light and dark bands caused by the waves overlapping, reinforcing each other in some places, canceling out in others. This is something particles alone can't do. So the conclusion seemed obvious. Light must be a wave. But then, something strange happens again. Because when you lower the intensity of the light, when you send it through one photon at a time, that same pattern still forms. Not all at once, but slowly. One dot at a time. Each photon arrives like a particle, a single point, but over time, those points build the exact same wave pattern, as if each photon somehow went through both openings at once, interfered with itself, and then decided where to appear. Now the wave explanation starts to break down too, because waves don't arrive as single points, and particles don't interfere with themselves. So what is light actually doing? It's not switching between wave and particle, like flipping a coin. It's behaving like something deeper, something that can produce both behaviors, depending on how you look at it. And this is where the idea of light becomes less familiar, because instead of asking, is it a wave or a particle? You have to start asking something else entirely. What kind of thing can appear as both? If light is not truly a particle and not truly a wave, then what is it? To answer that, you have to step away from the objects you can imagine, away from little particles flying through space, away from waves moving through a medium, and into something less intuitive, a field. In modern physics, everything is built on fields, not just light. Electrons have a field, quarks have fields. Every fundamental thing you can name is associated with a field that exists everywhere, not in one place, not traveling from point A to point B, but present across all of space, at all times. And what we call a particle is not a tiny object moving through that field. It is a disturbance, a small, localized excitation, like a ripple, not in water, but in the field itself. So a photon is not a tiny ball of light. It is a ripple in the electromagnetic field, a packet of energy that appears when that field is excited in a certain way. And that changes the picture completely, because now light is not something traveling through space, like an object moving across a surface. It is the behavior of the field itself, unfolding, evolving, interacting. And when it interacts with something, that ripple becomes localized, detected, measured, appearing as a single event, what we call a photon. So when you ask, what is light made of? The answer is not really photons. Photons are what we observe when the electromagnetic field interacts with matter. But underneath that, what light actually is the field itself and the way it moves. Once you stop thinking of light as little things moving through space and start seeing it as behavior of a field, something shifts, not just in how you define light, but in how you picture reality itself. Because fields don't behave like objects. They don't have edges. They don't have clear boundaries. They don't sit in one place and then move to another. They exist everywhere. And what you perceive as motion is really a change in that field over time, a pattern moving, not a thing traveling. So when light leaves a source, it's not like a tiny particle being fired outward. It's the electromagnetic field changing in a way that spreads through space. And when that change reaches something, your eye, a detector, a surface, it interacts. And that interaction is what you call seeing light. But the field itself never had a single location. It was always there. So now the idea of a photon becomes clearer. It's not what light is made of. It's what you observe. When the field transfers energy in a specific, measurable way, a discrete event, a point of interaction, a moment where something happens. And that's why light can look like a particle sometimes, and a wave other times. Because you're not seeing the field directly. You're seeing how it behaves under different conditions. So instead of asking, is light a particle or a wave? A better question is, what does the field do in this situation? And once you start thinking that way, light stops being something mysterious and becomes something more consistent, just not in the way you first expected. Now that the idea of a field is in place, another question quietly appears. If light is really a field, something that exists everywhere, then why don't you ever see that field directly? Why do you only see light when it hits something? Because every time you look around, you're not seeing light as it travels. You're seeing light after it interacts, after it reflects off a surface, after it enters your eyes, after it becomes a signal your brain can interpret. But the field itself, the thing that actually is light, remains invisible. And the reason for that is simple, but easy to overlook. You can only detect interactions, not the thing in isolation. Your eyes don't see the electromagnetic field. They respond to energy being transferred, photons being absorbed, signals being triggered. So what you experience as light is not the field moving through space. It's the moment the field affects something, your retina, a surface, a sensor. And this is true everywhere. Even in complete darkness, the field is still there. Light can still exist. But without interaction, there is nothing to detect, nothing to see. So, in a sense, light only becomes visible when it stops being itself, when it transfers energy, when it interacts with matter. And that means something subtle. You never directly observe light in motion. You only ever observe its effects, the moments where it ends, not the process of how it gets there. And once you realize that, it changes something fundamental, because it means your experience of light is not the thing itself. It's the trace it leaves behind. Now that you're seeing light as a field, its most famous property starts to make more sense. The fact that it always travels at the same speed, no matter where it comes from, no matter who measures it, no matter how fast you are moving, it's always the same. At first, that seems almost impossible, because in everyday life, speeds add up. If you run forward and throw something, it moves faster relative to the ground. Your motion adds to it. But light doesn't behave that way. And the reason becomes clearer when you stop thinking of it as an object, because objects can be pushed, accelerated, given more speed. But a field doesn't work like that. The electromagnetic field doesn't need to be pushed through space. Its behavior is already defined by the structure of space-time itself. The way the field evolves, the way changes in it propagate, is built into the geometry of reality. So the speed of light is not something light chooses. It's not something that can vary. It's the natural rate at which changes in the electromagnetic field spread, like a rule or a limit written into space-time. And that's why it never changes. Because you're not measuring how fast something is moving. You're measuring how fast the field can change. And that speed is fixed. So when you move toward a beam of light, you don't see it coming faster because the field adjusts. Space contracts, time dilates, everything shifts to preserve that same speed. And this is why the speed of light is so special. Not because it's fast, but because it's fundamental. It defines how space and time behave. And light is simply following that rule. Up to now, light has been something continuous, a field spread across space, changing and evolving. But then something very specific happens. It interacts. It transfers energy. And in that moment, the smooth picture of a field suddenly becomes something discrete, a single event, a photon. This is where things start to feel strange again, because the field itself is continuous. It doesn't come in chunks. It doesn't move as separate pieces. And yet, when it interacts with matter, it behaves as if it does. Energy is not transferred gradually. It arrives in exact amounts, fixed packets, and those packets are what we call photons. But here's the important shift. The photon is not something that existed as a tiny object, traveling all the way from the source. It is the result of the interaction, the moment where the field transfers energy in a quantized way. So instead of imagining a photon flying through space, you can think of it like this. The electromagnetic field evolves continuously until it interacts. And at that point, the energy exchange happens in a single, defined amount, a discrete event. And that's what you detect, what you measure, what you call a photon. And this explains something that seemed impossible earlier. Why light can behave like a wave while it's moving, but like a particle when it's detected. Because those are not two separate things. They are two parts of the same process. the field evolving and the field interacting. And once you see that, the contradiction disappears. Light is not switching between identities. It is revealing different aspects of the same underlying reality. At this point, it's easy to drift toward a familiar idea. That observation somehow creates reality. That light only decides what it is when you look at it. But that's not what's happening. In physics, observation doesn't mean awareness. It doesn't mean a person watching. It simply means interaction. Any interaction. A photon hitting a detector. A particle colliding with another particle. Energy being transferred from one system to another. That's what counts as a measurement. And once that interaction happens, the system takes on a definite outcome. Not because it was waiting to be seen, but because it has now become part of a larger interaction. So when light behaves like a particle, it's not because you're looking at it. It's because it has interacted in a way that produces a discrete result. And when it behaves like a wave, it's because no such interaction has forced that kind of outcome yet. This keeps the picture grounded, consistent. It means reality is not being created by observation, but revealed through interaction. And that distinction matters, because it keeps physics from turning into philosophy too quickly. It keeps the focus on what can be tested, what can be measured, what can be understood through consistent rules. So light is not changing its nature based on whether someone is watching. It is responding to the physical conditions it encounters, the setup, the interaction, the environment, and what you observe is simply the result of that process. Now, if you return to the question, the one we started with, it doesn't feel as simple anymore. What is light actually made of? At first, the answer was clear. Photons, small packets of energy, tiny pieces of light. But now, that answer feels incomplete, because photons are not the full picture. They are what you observe when the electromagnetic field interacts with something. They are events, moments of energy transfer, not objects traveling through space in the way you first imagined. And the field itself is not made of anything in the traditional sense. It doesn't consist of smaller building blocks. It is more like a fundamental layer, something that exists as part of the structure of reality. So when you ask what light is made of, you reach a different kind of answer. Not particles, not waves, but a field. A continuous presence that can behave like a wave while it evolves, and like a particle when it interacts. And that answer might feel less satisfying at first, because it doesn't give you something you can easily picture. No tiny objects, no simple model, but it is more accurate, more complete, because it reflects what we actually observe, without forcing it into familiar categories. So light is not something built out of smaller pieces. It is something more fundamental than that, a way that the universe itself can carry energy and information. And once you see it that way, the question changes from what is light made of to what kind of thing behaves like this. Now, if you look back at light, it's no longer what it seemed at the beginning. It's not a stream of tiny particles flying through space. It's not a simple wave moving through some invisible medium. It's something more subtle, a field that exists everywhere, changing, evolving, carrying energy, without needing to be made of smaller pieces. And what you call a photon is just a moment, a point where that field interacts, where energy is transferred, where something happens that can be detected. So the next time you see light, you're not just seeing something travel, you're seeing the result of a deeper process, a chain of interactions, a field unfolding and then touching something in a very specific way. And maybe that changes something small, in how you experience it, because what once felt simple now has layers. What once felt obvious now feels a little more open, a little less fixed. And that's often how these ideas end, not with a final answer, but with a shift, a different way of looking at something familiar, something you see every day but rarely think about. When you imagine light moving through space, it's almost impossible not to picture something physical, a beam, a stream, something that starts somewhere and then travels to somewhere else, like a tiny object crossing a distance. But that picture comes from everyday experience, from how objects behave. And light is not behaving like an object, because from the perspective of a field, nothing is being carried across space in the way you imagine. There is no little thing inside the beam making the journey from point A to point B. Instead, what's happening is a change, a pattern, spreading. The electromagnetic field at one location changes, and that change influences the field next to it, and the next, and the next. And this chain of change is what you perceive as motion. So, light is not something traveling through space. It is space itself, responding, a structure evolving over time in a very specific way. And that might sound subtle, but it changes everything, because now the idea of distance becomes different. It's not about something crossing a gap. It's about a relationship being passed along, a kind of continuity. And this is why light doesn't need a medium. It doesn't need something to move through, because it is not separate from space. It is part of how space behaves. So when you see a beam of light, you're not watching something travel. You're watching a pattern unfold through the structure of reality itself. If light were a normal object, you could imagine matching its speed, moving alongside it, seeing it stand still. But that's where everything breaks, because light has no rest frame. There is no valid perspective where light is at rest. For anything with mass, you can always imagine that. A car can be still. A person can be still. Even an atom can be still relative to something else, but light cannot. No matter how fast you move, light always moves away from you at the same speed, exactly the same. And that forces something deeper to change, because if speed cannot adjust, then space and time must. Distances contract. Time slows down. Everything reshapes itself to preserve that one constant. And at the limit, something even stranger happens. The concept of time itself begins to lose meaning, because to define time, you need a frame of reference, a way to measure change. But at the speed of light, that frame does not exist. So when people say, from light's perspective, no time passes, it sounds like a statement, but it's not quite accurate, because there is no perspective to describe, no clock, no sequence, no before and after. And that tells you something important. Light is not just moving fast within space-time. It sits at a boundary where the usual rules of time and motion no longer apply in a normal way. There's another way to look at light that makes everything you've seen so far feel more complete, not as a thing, not even just as a field, but as information. Every time light moves through space, something is being carried. Not mass, not substance, but change, a pattern, a signal. When light leaves a star, it carries the structure of that star with it, its temperature, its motion, its composition, all encoded in the way the electromagnetic field is oscillating. And when that light reaches your eyes, or a telescope, that information is unpacked, interpreted, turned into something meaningful. So when you look at the night sky, you're not just seeing distant objects. You're receiving information that has been traveling for years, sometimes for millions of years, and that changes what light is, because it's no longer just energy moving through space, it's communication, a way for different parts of the universe to influence each other, to exchange structure, to reveal what exists somewhere else. And the speed of light is not just a speed, it's the maximum rate at which information can travel. Nothing can send a signal faster. Nothing can influence something else more quickly. So light defines the limit of cause and effect, what can reach you and what cannot. And once you see it that way, light stops being just something you observe and becomes something more fundamental, a bridge between distant parts of reality. You've probably heard this before. Light always travels at the same speed, no matter what. And in empty space, that's completely true. It never speeds up. It never slows down. It simply moves at the maximum speed built into reality. But then something confusing appears, because when light enters water or glass, it seems to slow down. Its speed drops. Its path bends. It behaves differently. So what's actually happening? Is light breaking its own rule? Not quite, because the key detail is this. The field itself is not slowing down. The electromagnetic field is still evolving at the same fundamental rate. What changes is the environment. Inside materials like glass or water, light doesn't just pass through freely, it interacts constantly. The field excites electrons in the atoms. Those electrons respond, absorb energy, re-emit it over and over again. And each of those interactions introduces a tiny delay, not because the field has slowed, but because the process has become more complex. So the overall effect looks like light is moving slower, but in reality, it's being interrupted, redirected, delayed by countless interactions, happening at incredibly small scales. So when you say light slows down, what you really mean is this. The path becomes less direct. The process becomes less continuous. And that distinction matters because it shows you something deeper, that even when light appears to change, the underlying rules stay the same. When light enters a different medium, like water or glass, it doesn't just appear to slow down, it bends, changes direction. And that bending is something you've seen countless times. A straw in a glass of water, a lens focusing light, the way objects distort beneath the surface. At first, it seems simple. Light changes speed, so it changes direction. But if you look closer, there's something deeper happening. Because from the field perspective, light is not a tiny object being redirected. It's a pattern, spreading through space. And when that pattern enters a region where interactions happen differently, the way it evolves changes. The field responds to the structure of that material. Some parts of the wave slow down more than others, and that difference causes the entire pattern to shift, to bend, to adjust its path. Not because something pushed it, but because the environment changed, how the field could evolve. And this same idea extends further, much further, because light doesn't only bend in materials, it also bends near massive objects, stars, black holes, even entire galaxies. Not because something is pulling on it directly, but because space-time itself is curved. So the field, once again, is simply following the structure it exists within, adapting, evolving, taking the path that is available. And that changes how you see motion. Because bending is not about force, it's about geometry, about how space is shaped and how the field moves within that shape. After everything we've explored, it becomes harder to think of light as something you can point to, something you can isolate, something you can say, This is it, because every time you try to define it, it slips into a different description. A particle when it interacts, a wave when it spreads, a field when you look deeper. And none of those are wrong, but none of them are complete on their own. Because light is not a single thing, it's a behavior, a way the universe carries energy and information through the structure of space-time. And that's why it feels so difficult to pin down, because you're trying to describe a process as if it were an object. You're trying to give it a shape when it doesn't really have one. So the closer you get to the truth, the less familiar it becomes. Not because it's confusing, but because it doesn't fit into everyday categories. And once you accept that, something relaxes. You stop trying to force light into being one thing, and instead, you start to see how it behaves, how it appears, depending on the situation. And that's a different kind of understanding. Not a fixed answer, but a clearer picture, one that holds together, even when the details feel strange. Right now, light is all around you, from your screen into your eyes, carrying patterns, carrying information, quietly shaping everything you see. But beneath that simple experience, there is something deeper, a field, present everywhere, changing, evolving, never truly still. And every time light reaches you, you're not seeing the field itself. You're seeing a moment, an interaction, a trace of something more fundamental, something you never directly observe, but always experience through its effects. So as you begin to relax and let your thoughts slow down, you can hold on to that idea that even something as familiar as light is built on something far more subtle than it appears. And if you enjoy exploring ideas like this, slowly, calmly, and in depth, then you're in the right place. This is science sleep theory, where the deepest ideas in science become something you can simply drift into. Sleep well.